For the first time in over half a century, human beings are leaving the immediate vicinity of Earth. Artemis II functions as a 10-day high-speed stress test to verify that trajectory models and newly built life support hardware can reliably sustain a crew in the void of deep space. The crew running this test reflects the modern composition of the space program. NASA astronauts Christina Koch, Victor Glover, and Reed Wiseman, alongside Canadian Jeremy Hansen, represent the first woman, the first person of color, and the first non-US citizen to travel to deep space. Pushing a crew out of Earth's gravity well requires the Space Launch System, a heavy-lift rocket capable of throwing immense mass toward the moon. For 10 days, those 4 astronauts will be entirely dependent on the Orion spacecraft, named Integrity. They have to prove that its environmental controls, scrubbing systems, and pressure seals can function as a self-contained lifeboat in a vacuum. While the Apollo missions proved humanity could reach the moon, the Artemis program aims for a permanent architecture. This flight serves as the foundation for that future. The performance data gathered here is the prerequisite for the landing missions to follow. After launch, Orion enters a highly elliptical, high Earth orbit, taking exactly 24 hours. During this loop, the crew systematically tests the capsule's vital functions, evaluating water dispensers, firefighting masks, waste management, and thermal regulators under real spaceflight conditions. The pilot then takes manual control of the spacecraft to perform proximity operations, deliberately maneuvering Orion near the spent upper stage of the SLS rocket to evaluate its handling qualities in a vacuum. This entire phase is built around a single safety constraint. Still captured by Earth's gravity, if a primary system fails, the crew can rapidly abort and return in hours. Only after every system passes inspection does Mission Control open the gate, authorizing the crew to leave Earth's orbit. With the spacecraft verified, Orion fires its main engine for the translunar injection, a massive, precise burn that propels the crew out toward the moon. This plots their exact course, a free return trajectory. It is the mission's core failsafe. By aiming for a specific point, Orion allows lunar gravity to physically capture the capsule, pull it around the far side, and slingshot it directly back to Earth. This means the mission doesn't require a second engine burn to initiate the return. If Orion's propulsion system fails in deep space, the laws of gravity ensure the crew remains on a path toward home. When hardware breaks hundreds of thousands of miles from Earth, trajectory becomes the ultimate insurance policy. At its closest approach, the trajectory carries the crew roughly 4,700 miles past the far side of the lunar surface. Because of the geometry of this specific slingshot, these 4 astronauts will travel further from our planet than any human in history, breaking the distance record set by Apollo 13. From that vantage point, they will witness a view seen by only a handful of people in the 20th century. Just as you see in this photograph taken by the Apollo 8 crew, they will watch the Earth rise over the barren lunar horizon. In those hours, they will gather crucial telemetry on deep space radiation exposure, fulfilling a scientific objective while marking a profound symbolic return to our furthest reach. Completing the flyby means the capsule is now essentially falling all the way back to Earth. By the time Orion hits the atmosphere, it will be traveling at 25,000 miles per hour. This creates a severe thermal environment, which poses a specific problem. After the uncrewed Artemis I flight, NASA identified unexpected erosion in the avcoat material on Orion's heat shield. The original plan used a skip re-entry, dipping into the atmosphere and bouncing out to bleed off kinetic energy. To protect the compromised heat shield, engineers mapped a steeper, direct entry profile, reducing the time spent inside the most destructive thermal zones. By altering their angle of descent, mission planners are using orbital mechanics to compensate for the physical limits of the hardware. The capsule will then splash down in the Pacific Ocean, where U.S. Navy recovery teams will pull the crew and their spacecraft from the water. Returning 4 astronauts safely after 10 days in deep space transforms the moon from a distant destination back into a reachable home, clearing the final path for the missions that will eventually lead to Mars.